Deterioration modeling. So, first of all, in we can start with the International Roughness Index. That's basically the core part of this analysis. That's basically the IRI. Then, and when it's a higher value, it indicates that it's like worse, like a pavement deterioration, and when it's less, it's like a better road. So the deterioration of road surfaces are influenced by many factors, but luckily in the Excel that we have, we could adjust to a Markovian system because it satisfies well its properties. So we will use like all the data from the past and pass it to the to the present, and also to make a to the future in the probabilistic system. Basically, to know how is the road gonna be in the future. Now, the numerical indicator that we used, we basically uh, put it in three ways. When it's less than 2.99, it's good, and if it's in between 4.99 and 3, it's regular, and if it's more than 5, then it's bad. We put it this way, so it's like a simpler way than, like, for example, use 5 values. So we use 3, and it's accurate and also simple. Also, this categorization is used in Mexico, so with the values that we just talked about. So the next step was defining the state vector, and it's basically the probabilities. And now defining the initial state vector system, and we defined the initial state vector system by analyzing the data of the road segments in 2021. So it's put just right there. So the next step was to reorder all the data that we have, and we did that, making it, for example, not for example, we did it in all the columns. We had we had right and left, but we actually did we did an average of those, and we did the transition probability matrix that is just put in here in the Excel. Through all the years. So for example, in this year, all the S1s that stayed in S1, the S1s that went to S2, the S1s that went to S3, and that's how all the Excel is made up. And we finally have the transition of 20 to 21. So having this probability matrix, we multiplied it by the current state vector to get the future state vectors until the year 2026. And then we analyzed and interpret the results. Also, before the results, it's also important to talk about the model limitations. First of all, the model doesn't consider a future variability in factors that can affect road conditions, such as climate, traffic patterns, and all of that. The model considers the average from the left and right road, as I said in the as I just said. So with potentially this grading difference between them. And the model considers changes on a yearly basis, which can miss short-term or seasonal variations. So the results obtained from the Markov change model reflect the behavior of the road condition changes over the time, and based on the circle data from 2016 to 2021. So by applying this matrix, we could see all the changes through time, and which show, for example, the road, if it's good, or if it's going better or worse, And well, obviously it's natural that the road goes like worse, but we can see a great pattern in it with the Markov chain model. So as we, well, this is the basically the result, and we can see that, well, the probability of the road like going into that state in the column is like S1. All the roads that are in quality S1, which probability they have to stay the same or to change. For example, it has a 94% probability to stay in S1, or point 0, well, 4% basically to go to S2, and less to go to S3, and that for each category of road. Well, yeah, if it's good, real, or bad. And with this table, we can see that, well, the matrix tells us that the segments have a really great probability of staying the same, knowing that no urgent maintenance is required, but maybe there could need it in the future. And as a final conclusion, we can see that all the results here say that the road is actually, well, deteriorating, but it's like a normal deterioration speed. So we can see at the end, it increases from 1.74 to 1.77 in 2026.